So this is part 3 of the exam 1 review. Okay, so we've seen this before, and the thing I want you to take away is that in order to be valid, something must also be reliable. Like in target C, it was valid, but it is also reliable. If it wasn't reliable, then it couldn't have been valid. However, you do not have to be valid in order to be reliable, like in target A. So keep that differentiation in your mind. And reliability is consistency. Same scores show across various circumstances. And validity is accuracy, measuring what the researcher intends to measure. So that's why target C represents validity, because hit what they were trying to hit. Okay, reliability. So we have these two sources of error, trait error and method error. So trait error are characteristics of the participant that contribute to unreliability. So characteristics of the participant. Method error is an error with the test itself or the researcher or the testing circumstances. So error can also be classified into these two subtypes, random error and systematic error. Random error is imprecision resulting from natural fluctuations, usually things that only happen once or twice, due to chance. So that's a big thing, due to chance. We assume that the errors will just normally distribute around the true score. So random error is not a huge deal, at least in comparison to systematic error. So systematic error is when there is something systemically wrong with the research process. Something with the actual design that is wrong, and it's carried out with pretty much all the participants rather than it being a one-time thing or even a two-time thing. And it has major ramifications. It is the most dangerous kind of error of these four types we've talked about. So we have this. So we have the true score plus error equals the observed score. We never really know what the true score is because there's always a little bit of error. And then those two combined get you the observed score, what you get in your study. So, and then error can be divided into trait and method, and then random and systematic. Although there's pretty much never systematic trait error, but you can have random trait error, random method error, and systematic method error. Okay, so let's do some examples. A survey asks about your opinion on how well a political leader has handled things. The response options are very well, well enough, okay, and other. What kind of error is this? Is it random trait error, random method error, or systematic method error? It is systematic method error because the survey was designed that way, and then that's what all the participants got. A research participant has dyslexia and misreads some of the survey questions. What kind of error is this? Is it random trait error, random method error, systematic method, or systematic method error? That is random trait error because it is a problem with the research participant rather than the researcher or the testing circumstances. And it is random because it's not like every participant had that same problem. It just was a one-time thing. Okay, a researcher brings their child with them to the research facility one day because he could not find a babysitter. The child cries the entire time, distracting the research participant. What kind of error is this? Random trait error, random method error, or systematic method error? It is random method error. So it's a problem with the testing circumstances and the researcher rather than the participant. But it's random because it was just a one-time thing rather than it happening every single time. Okay, types of reliability. So we have test, retest, inner item / internal consistency, inner rater reliability, and alternate or parallel form. So test, retest is when someone takes the same survey / test twice at 2 different time points, and you're expecting the 2 scores to be related. Okay, and then inter item / internal consistency. When you have multiple items measuring the same variable, the same items should be related to each other. So that's when, so you have multiple items measuring one variable. The items should all be related to each other, similar to each other. So we had the example of depression, and these items: I feel depressed, I feel worthless, I often feel sad. And you measure this with Cronbach's alpha, measured on a scale between 0 and 1. And you want at least a 0.7 or more. Inner rater reliability. That's when 2 or more researchers are rating the same thing. The scores should be similar. Oftentimes they'll have student researchers doing the assessing. So that would be like if 2 students observed the same behavior and they both agreed that the behavior, they both came to the same conclusion about what the behavior was. They would be reliable. Although keep in mind that this is still reliability, because maybe they both came to the wrong conclusion, but inner rater reliability is just measuring if they both came to the same conclusion. Okay, and that is measured with Cohen's kappa, scale between 0 and 1, and again, you want at least a 0.7 or more. And then alternate parallel form. This is when there are 2 different versions of the same test, but the same people wrote the different versions. Do the different versions have enough in common that a person taking the test would get the same score no matter what version they got? So we used the example of ACT before, where there are multiple versions of the ACT, but they're all the ACT test. And people oftentimes get the same scores with one form as they do with another. Okay, examples of reliability. So 2 student researchers observe the behavior of a research participant. One student comes to the conclusion that the participant is stressed, while the other comes to the conclusion that the participant is relaxed. What kind of problem is this? Is it test-retest reliability, inner item or internal consistency, inner rater reliability, or alternate form reliability? and that is inter-rater reliability. You have the two student researchers both rating something, and they had poor reliability because they came to different conclusions. Okay, a researcher uses 10 items to measure relationship satisfaction. After the data is collected, the researcher looks to see if the items are all related to each other. What kind of reliability is being tested? I'll let you read the responses yourself. It is inter-item or internal consistency. A researcher found that their scale had a Cronbach's alpha of 0.9. Does the scale have good internal consistency? Yes or no? And it is yes. Internal consistency for Cronbach's alpha should be at least 0.7 or above. So 0.9 is definitely good. The GRE testing entity comes up with 10 different versions of their test, all of which are still the GRE. What kind of reliability does the GRE have? Is it test-retest reliability, inter-item/internal consistency, inter-rater reliability, or alternate parallel form reliability? And that is alternate or parallel form reliability. The researcher found that their observational study had a Cohen's kappa of 0.45. Did this study have good inter-rater reliability? Yes or no? No, it did not. Anything below 0.7 for Cohen's kappa is bad. You want a 0.7 or above. Okay, we'll stop the video at this point and upload this portion, and then